Wow. Firstly, before I get started, this week's been really amazing. This conference has been really amazing. So if you see any of the organizers, please tell them they're doing a fantastic job. Any of the staff who are helping out. It's just been an amazing conference. So I'm really glad to be here, part of it. So I'm David. I'm going to be talking about flakiness isn't from your test frameworks. I'm going to talk through some of these things, but like a little bit about me. I chair the W3C Browser Testing and Tools Working Group. That is the group that produces the WebDriver specification. You've heard people talking about WebDriver BiDi. That is a specification going into browsers. We had Laura talking about it, how it's going into WebKit. It's in Firefox, it's in Chrome, and so it's there. I've been a Selenium committer for, I think I worked it out this week, like 17 years working on the project, so deeply care about it. Wrote books, and these days I head up developer relations and the open source program office at BrowserStack, where I get to work on these things still, because I deeply, deeply care about it. So today I'm going to talk about what I consider flakiness. Hopefully it matches with your ideas of flakiness. If it doesn't, we can have a chat afterwards. How we think about testing. How software generally works. How does this affect your tests? And I think like all of these things, as you think through steps, really matter. And hopefully at the end, I will be able to do Q&A and answer your questions, because I'm willing to bet there'll be some amazing questions. Cool. So, what is flakiness? To me, I try to be super simple with this idea. Flakiness is a test that fails randomly. You do not know why it fails. And then from there, you like get angry, you cry, you might have a glass of wine, and you start moving on from that, right? And the truth is, it's not easy being green, right? When we write tests, we have to integrate databases, user interfaces, microservices, CDNs, observability. The keynote this morning was fantastic, right? Like, I looked at it and I was like, I'm following on from that, and it's just like, it's half the content has already been talked about, but in a different sense, right? You've got all these things, but when we start creating tests, they start to cause problems. And that's where it's hard being green, right? It's not easy being green, sorry. And I learned this quite heavily when I was at Mozilla. I tried to find something that was orange. Because when I was at Mozilla, we had this concept called the war on orange. So at Mozilla, a flaky test was an orange test, right? It's not green and passing, but it's not red and failing, right? We've noticed that there is a potential for it to be flake. But like anything that's war on something, it was bound to fail, right? The war on drugs that like the US, the UK have been doing for years, it's been going for a very long time, and I don't think it's actually solved anything, right? Other than put people in prison who might not need to be there. The war on orange, we never solved flakiness. So when I left Mozilla 5 years ago, a commit to Firefox could kick off 2,500 compute hours worth of compiling, then testing. And the main reason is that there's this huge matrix of what needs to be tested, from mobile to desktop, and desktop would need to be all the different operating systems, but then you've also got like when you're running tests, you want to check if there's any memory corruption while that's happening, and it starts growing. And we got to a stage where like there's over 100,000 test files. That's files. Inside there could be multiple tests, right? Having everything green just became impossible. And I think it's really important that like if you get to a certain scale, you give up on trying to be green because it's a road to nowhere, but you then start doing other things to mitigate it, right? Because the key thing that hopefully by the end of today you walk away from here is going, I have confidence in my test suites, right? I know exactly when it's going to flake, and I'm okay with that, and we go from there. How do we think about testing, right? The key thing here that I think a lot of us do, I certainly do, and I've seen it through like customers when I've been at BrowserStack and when I was at working in developer experience at Mozilla. People tend to think that tests work like this. You have step 1, you have step 2, step 3 onwards, right? You do that very simple thing, right? You have a known start point, a known end point. You do one succinct thing very well, and your test is finished, right? Unfortunately, the way we're thinking about our tests tends to actually be a lot like this, right? We have all these things going around, right? Your test is like doing this one thing, and it kicks off another thing, and it creates this huge jumble of things. But the human brain is amazing, right? If I ask you, can you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, right? Like I had in the previous slide, you can spot them. Super, super easy. But the way software works is kind of like this and not like this, right? And it's like this, right? For example, it doesn't matter what order the letters are in a word appear. The only important thing is the first and last letter are in the right place. The rest can be in a total mess, and you can still read it without problem, right? For English speakers, I'm pretty confident you could read that really quickly, right? Your brain just fixed all these things into place, and so when you're writing your tests, computers are very like, I've told you to do that instruction, not to kind of do what my brain thinks you should be doing. Right? And the key problem is that we start thinking along the lines of like multi-platform, right? In the keynote today, like people's Almudena, sorry if I've mispronounced, was talking about like people are moving to mobile devices, but the mobile is still speaking to a server, and that still needs to be performant, right? I started playing Fortnite at the beginning of the year with my kids, right? They were really like, Dad, you got to play with us. And I'm like, okay, cool. We have a desktop computer. I have a Switch, and they were like, we'll put it on there, we can play. And I started playing with a control like that. But I'm old enough to have been playing Counter-Strike when it like first came out, right, on a desktop. And I got used to being on a desktop, and now trying to aim with like a little control, doing things like that, and you're doing that. It doesn't make sense because, to me, right, you get used to what you feel is correct. You do things like that. And then we have these multi-platforms, data coming from different places all at once. And all your test says, navigate to here, click this button, wait for this thing, assert. Simple, right? And as I said, like, software doesn't work the way you're thinking. Software has a lot of instructions, but as the keynote said today, performance is king, right? We tend to think sequentially, but when we write code, we tend to write it with asynchronicity in mind, right? You might not be thinking it, but like the tools that you're using are thinking about it, right? Databases work that way. If you're using web, you're kind of having JavaScript firing, doing things the way network requests are working. They're all kind of firing off at different times to try prevent that white screen that was mentioned today, right? That anxiety that people get, right? And it's because we're trying to get performance. We want people to do it. I used to do performance testing, and a lot of it was trying to figure out like what felt like a conspiracy theory, right? You just look at it and go, oh my God, none of this makes sense, but it all makes sense at the same time. Just believe me, I've got this crazy idea. And you start to kind of pull things back and you trim it down. But at the end of the day, the tools are trying to be as performant as possible. In a browser, if I tell it to do things sequentially, it will literally lock up, right? If you've been doing web development and web testing for long enough, for years, if you had an alert, it would literally lock up the browser, right? No tab would work, nothing like that, until you got rid of that alert. Nowadays, alerts are slightly better, but you're still recommended never to use it. But it's this thing of like software moving around at different speeds. So, how does this affect your tests, right? Like I've kind of talked high level about asynchronicity. We need to fire up a browser. We need databases. We have CDNs. We have like all these things that are kind of just flowing into different places all at once for us to be able to use it. And I'm pretty sure one of these frameworks over the years has solved this. Right? So, if we take a simple test, and I've tried to make it as simple as possible, right? We're going to navigate to a page. We're going to fill in a form. We're going to submit that form. And then when the page comes back from the submit, it's just going to print everything that was filled in the form, so it's just a static page with the answers. Do we all agree that's a kind of fairly simple test case? Right? The problem really lies in the first step. In a browser, navigating to a page is not simple. It's not simple in the slightest. There are multiple things that can kind of influence it, right? We just want to navigate and wait, right? The thing that a lot of frameworks over the years have told you is that, like, you don't need your wait libraries. We've solved that. The reality is no one solved it. But the thing is that when you navigate, you ask it to load a page. That can be simple if it's just one thing, but you could still have that blank screen, because then it fires off another network request, because the page is loaded, but now we actually need to load in the front end at that point, right? If you're in that state. A lot of the performance testing, performance gains that people have been doing over the years is that, like, you would get a static page and then inject JavaScript afterwards. Then we move to front-end rendering, like Ember, React, all of that. Do all of that. And each time those things happen, you never know when something is actually fully rendered, because at that point, the browser, like, it tries to do these heuristics. I'm sure you've all heard of DOM content loaded, right? The basic idea of DOM content loaded is that, like, all the HTML is there. All of the images that were in the HTML at the beginning have rendered. And that the initial JavaScript has been downloaded and possibly executed. Possibly, right? Because you never know if it actually has, because people might have written set timeouts and things like that, but it's been told, you can execute now, and we're there. And so suddenly, wait for page load suddenly becomes a lot scarier in what we need to do. And if we're doing web testing, we've been told by multiple frameworks that it's a solved problem. Selenium even has, like for years, tried to do its best, but at least what it says is that we'll wait for this point to happen. Anything else that happens after that, we don't consider part of the page load, and you might need to extend it. We've seen Cypress do the same, Puppeteer, Playwright. And there are people who are writing blog posts on how to get Playwright. How do I wait for a page to load? In our simple test case, we have not moved off step 1 yet, right? And we're already Googling how to do basic things. Cypress, again. I don't blame these frameworks, by the way. I think we all suffer from the same problem, and it's really hard. We have Playwright. Avoid flaky tests in Playwright. Right? This is their LinkedIn post, right? Again, this is not me bashing Playwright. As Jonathan Lips said yesterday, is that I like to point out when people are being hypocritical, right? I said to him that he called me a bad guy for always doing it, but I want people to know the truth, right? The fairness in everything, and to remove enough of the marketing bullshit that's out there with all these frameworks, right? At the end of the day, all we want to be doing is our jobs, delivering high-quality products, delivering a high-quality web, right? And so playwrights are telling you, don't write your Playwright code that way, write it this way to avoid flaky tests. Flakiness is inherent. Puppeteer, I wanted to wait until it is completely loaded. In browser terms, completely loaded doesn't make sense, right? If you've ever worked on a browser, if you saw Laro's talk yesterday, he understands browsers. Go have a chat with him too. He's fantastic. He will tell you. Some of these things just don't make sense at that point, right? It's a heuristic. We try to solve it to that point, but it's not always solvable. And then everyone's favorite. How do I get Selenium to do it, right? The reality is, every framework has the same problem. We have these things, we do it. And for the most part, Selenium would be able to solve that easy test case. Playwright, Cypress, all of them. But it starts to get a lot harder as we move forward. So I'm just going to have a quick drink. And the problem, really, with a lot of this stuff, so everything I've said, I've been talking about page loads, but the problem is it's the wait problem. How do you know when a wait needs to finish? So in this case, the answer is in the halting problem. Who here knows what the halting problem is? Okay. So the halting problem in computer science is a P equals NP type problem, which means it's unsolvable, right? You cannot get there. And honestly, if you ever were to solve the halting problem in web testing or mobile testing, I can guarantee you'll probably be a billionaire by the end of next week. Like, it's that big a problem. We have industries that, like, people creating frameworks. We have all of these things. So if you can ever solve that, you'll be a very rich person. And the halting problem really is about creating an algorithm that knows that when something needs to finish. So in this case, I keep using the example of a page load, but it could be we fired off some JavaScript, it is loading some data back in to a web page. It's that wait. How do you know when to stop waiting? And the halting problem, multiple people have tried to solve it, but it becomes very hard very quickly. Like, the initial cases are super easy, right? And this is why I'm sure you've worked at a company where we're leaving Selenium, we're going to write it in Cypress. And you start doing it. Your first 10, 100 tests, perfect. There's no flakiness. You go beyond that, and suddenly flakiness starts rearing its head. I can guarantee if you were to rewrite the same test suite from Selenium in Java to Selenium in Java, brand new thing, no assumptions, and build it out, you would get the exact same result. Because the problem you're trying to work around is problems that are really hard, which keep us in jobs. It's never the tool, it's the kind of underlying thing that we never think about, because our brain just goes, I'm making this simple request, I'm getting this simple thing back. And I think it's really important. And unique problems require unique solutions, right? Selenium for years had implicit waits, explicit waits. When Puppeteer first came out, they famously said you wouldn't need a wait library. Then they added a wait library about 6, 7 months later. Cypress said you would never need a wait library. They then added a wait library because it needed to wait for certain things that people were doing. Same happened in Playwright, right? We keep making the same mistakes because we keep thinking that everything is as simple as it is. But it's not really. And we just need to think about where everything is coming in and how we can do it, right? And as I say, but Selenium's flaky. This is the thing I keep seeing on social media all the time. I see it in blog posts all the time. And generally, it's because people are taking these oversimplistic views of the world, blaming a tool, but never kind of understanding things. I'm sure we've seen our friends going, I can't get a React job. React is just JavaScript, so it's just a JavaScript job, right? There's framework and you get to learn it. But if you have good fundamentals of how the underlying works, you can go do amazing things, because everyone in this room and everyone watching are smart people who are just trying to do the right thing. And this leads me to, this is my concept, the Overton window. It's generally around political terms, but it's if you've ever watched the news and you keep seeing politicians and they will say the same boring thing over and over and over, it might not be true, but they keep repeating it. But because people keep repeating it, what they believe is true moves with them, right? What we've seen over the years in the Selenium space with Selenium versus series by companies and by YouTubers, influencers, is that the Overton window in this space has made Selenium the problem because it is 20 years old. But if you look at WebDriver.io, Nightwatch, Cypress, those projects are like over a decade old too, right? And the Overton window for the old frameworks is moving to a space of, you're not shiny, you are the problem, but the problem is just pure marketing. And we can combat this, because the flakiness that we are trying to solve is in how our tests are broken down, how we break down our applications, how we think about our applications long term to make those tests really stable, right? We have the testing pyramid for a very good reason, right? Because the tests at the bottom are the most stable tests you will ever write. The tests at the top of the pyramid are going to be the most flaky tests that you will create. And you should try balance what you should do between those 2 points rather than make it either top-heavy. I call it the testing Christmas tree because it spreads out at the top again when people do component testing and then goes to end-to-end testing. Or I think Richard Bradshaw calls it the testing hourglass, right, where we put too much on the top, which then creates these scenarios where our developers are getting frustrated because they've had to fire up all these things, their browser, their database, everything, to run a test. That test then is flaky because it's taking a lot of resource at that point, and the test is only designed for a certain type of thing. Also, don't run your CI on Raspberry Pis. That will create flaky tests, I can guarantee. Oh, wait, there we are, sorry. And with that, I think I'm finished. 10 minutes for Q&A. 10 minutes for Q&A. I've got Q&A. The QR code, as Pooja mentioned in yesterday's talk, is for the browser stack Discord. If you have any questions or things like that that you don't want to ask me today and you want to ask me later, that's a very easy way to get hold of me very quickly. Please do join. And yeah, if you have questions, I will try my best to answer.
Love a good Discord. Thank you.
Hello. Thank you, David. Really interesting talk. On the topic of loading a page, right now I'm working with Playwright, and at the beginning we had like a standard to say you need to wait for network to be idle, and that was like the de facto thing that you should do, and eventually it was like kind of rejected by the same Playwright folks saying, don't use this. At the beginning it was use this, but then don't use it. And for us, it makes sense because we had a lot of GraphQL things going on, and it was a mess. Do you think it would be worth it to invest on your special case to make the page load more resilient with whatever tool you're using? Like, I know I have hundreds of GraphQL requests, and I can kind of understand when the page is loaded, but it will never be loaded. So should we invest on that or not?
So I think requests are never going to stop, right? I always thought what Playwright were doing with the network idle is very simple and for the simple case it's perfect, right? But as you quickly find out, the minute you start adding like different things, I would hate to be a commerce website and do that because like they are just loading different things, analytics, all of that all the time. I think for the most part, it's like whenever you're doing a test, when you think a page is loaded, try find the most stable point at that. So if there's an element on the page that you know, like, because like with GraphQL, you're probably going to be loading different points at different things. Find that most stable point that's going to happen. And if that fails, you probably want your test to fail quickly anyway at that point, and you can do it. But I think to me, you need unique solutions for your thing, right? Like, not everyone's going to have an application like yours, right? There might be someone who like needs a stable WebSocket. Great network, it's never going to be idle at that point because it's just constant. Try find that like one thing and go for that, and then from there, your test needs to build outwards, or kind of, not necessarily a test, but it could be in a before, right? But like find the stable point. The way I've always told people to write a test is like, start from a known place, do one small thing really, really well, and then return back to that thing. And so in that case, like if you know these things are going to happen, it could be the second test, it knows it needs this stable element because like 5 GraphQL things have happened, right? And then build it outwards. I think it's that you should always do, but I don't think you'll ever find the right solution. So like when I was talking about the war on orange that Mozilla was doing, our aim was to have, I think, about 98% green, right? Because after that, the return on investment fixing and making those things stable reduced. So the other part is that, like, if you're doing it, like, instead of, like, having all these tests or doing all that, I think it was Simon Stewart said it at Selenium conference London, where he said, only write one Selenium test. Does that sound familiar? Yeah. Write one Selenium test. But his point was, don't write just one, right? Like find that one impactful test, focus on that, make that stable, make that good. Then if you need to add another one, that's fine, because you start doing it. Don't just write tests for the sake of writing tests, right? Be thoughtful, because then you start removing the flake as well, because like you don't need all these things, and that's where you got the like, I don't need a whole database for this. I could do a component test and just for that type of thing, and I just have my one test that loads everything, and we know it might be flaky.
I don't see any other hands. Let me ask a question. The way in which I have had success in this in the past, which I don't think is possible at Mozilla, was I worked with the software architect who was in charge of the site that I was testing, and they implemented something like an invisible pixel that every individual page developer would say, as soon as I render this pixel, I consider the page to have been satisfied. It's not finished, but it's the point of being testable. So we instrumented the product is my point.
Yeah.
I'm curious to hear your thoughts on that.
So you could do that. The problem with like Selenium is that like you would know that the element is there, but you have no idea that the element is rendered, right? Like that is the thing, because you can see that the HTML has that element, but do you know that like when it's gone off to the network to request that element to be downloaded, has it actually completed, things like that, right? So I think in a simple case, yes, that could happen, but there's a lot of like extra complexity because you're now adding the network, right? Like I'm sure when we were all at university, we were told like in terms of how data transfers, like the CPU moving data about is kind of like walking to the end of to Marcus. But the minute you go to a hard drive, you're effectively going to the moon. If you go into the network, you've gone like out into extraterrestrial space. So it's like it becomes huge amounts, right? And we need to sometimes just remember those fundamentals that we learned, right? Like, and then try just like tweak, find that unique thing that we want. Does it need to be a Selenium test or Playwright or whatever? And then go from there. Like at the end of the day, I think everyone in this room just wants confidence in their test suite and their product, like that, and you need to find whatever that means.
Yeah, I think there's opportunity to collaborate with the engineers at your company too.
Oh, 100%.
To me, that's the main thing. If they understand how the tests work, they can help you with this problem, which will be bespoke to your test environment. Anyone else?
Hi, thank you for the talk. It was really interesting to see where we're going to. And your take is flakiness in our tests isn't down to test framework, right? So I'm just curious, can you name like 3 things which I need to consider to make my tests less flaky, like in general?
So the key thing here is like, how is the data coming in? I think is probably the best thing, right? So as the gentleman in the front was saying, it's like page loads, then it does all these GraphQL stuff, right? Like, do you need all of that stuff, right? So Selenium, Cypress, Playwright, they all have like network interception that you can start doing, and you can just quickly return, right? So it doesn't go off onto the internet. And you like, think about that. It's like, oh, if I added that into my test, that could remove potential flakiness, but it might not be realistic to the world. But now you have a test that does that thing, does it well with the data it has, and you can start doing that, and then try work out what you need. The key flakiness that 99 out of 100 flaky tests are down to some form of wait, right? I didn't wait for an element to load. Like there was a 404, so it would never have loaded, or network problems. I always joke with a lot of my colleagues that like networks are more down than they are up. You just never notice it because of like how TCP works, right? Type of thing. And so it's just finding that, like breaking it down. The key thing that for everyone here is try create data of when tests are flaky. Right? What is that? How often it happens? Where it's happening? Things like that, right? A lot of cloud vendors have test insights, right? BrowserStack has a thing called test observability, which allows you to like track how often a test is flaky, why it's flaky. In my past, when like before the cloud, right? When I was working in Mozilla, we had our own data centers. We had flaky tests because memory corruption. I mean, what it turned out when we started tracking everything was tests were always flaky on this one machine. And it was like, oh, we look at it and it's like, oh, actually, it needs new RAM, so we need to replace it, right? But get that data. Figure out what that data means to you, because it's going to be unique to you and your colleagues, and then go, oh, okay, I'm going to fix this thing really well now, and then move on from that.
So basically, it's gathering the data, building the confidence, and finding out which solution works best for you.
Yeah, and so like in the keynote today, they were talking about like how they had screens everywhere, right? And like that could be part of like the testing department's screens or the development department screens. It's like we've got these flaky tests. It's always these things. Why are these flaky? And then like, oh, they're only flaky 1 out of 1,000 tests. It's not worth your time to fix it realistically, right? Like, and say that to your developers. Be confident in saying, we can't always be green, but we have confidence it's doing the right thing, right?
Okay, thank you.
Cool. Thank you, everyone.
Thank you.
Thank you, David.